Welcome to Code Sutra. This is the part 3 of the array series that is actually included in the interview series. In this video, I will be talking about prefix sum, also called as cumulative sum. First, I will discuss about the algorithm, what exactly is prefix sum. Then I will discuss about couple of questions that was asked in Amazon. These are not very hard level questions. These are like mid-level question, medium level questions, but Amazon actually asked these questions, and these questions actually form a basis for other hard level problems. Hard level problems are nothing but you break them into few of the medium level problems. So if you understand these problems, you will be able to understand hard level problems also. And finally, we will be discussing this question which was asked in Facebook and as well as Microsoft. So without further ado, let's get into the algorithm. So what is prefix sum? What is this technique? So this is one of the most intuitive techniques. You will actually be using this already in real life, but we don't know how to use it in arrays. Okay. So for example, let us take this array for example. And I think all of you know cricket here, right? Even if you don't know cricket, think of it like any sports. And these are the scores at the end of each over. At the end of first over, the score was 8. At the end of the second over, the score was 6, 4, and so on. So you and your friend started to watch the match. Think of it like this. You started to watch the match from the very beginning, and the time went by, and it was the 5th over. Okay, so now your friend gets a call, and he goes to talk, and the time goes by. Now you are at the end of 8th over. Now your friend comes back, and he says, "Hey, I just went to talk for a couple of minutes and the score is already 30. So how did he say this? Did he add these 3 numbers and said this? No, right? Because he had access to the scoreboard. He can directly subtract them and say this. Let me show you. For example, this is the array that we are given. That is the scores of the individual over. And this is the cumulative sum. What is the cumulative sum? 8 and 6. The sum of these two is 14. Then again to this 14 we will add 4. Again to this 18 we will add 10. What is it? It is the running sum or the cumulative sum of element after element. For example, if you take this 60, it is just the sum of all the elements until that point. So what happened in the particular example that we shared? Your friend left when the score was 40 and he returned back when the score was 70. So he need not calculate the sum of all three. He just can remember 70 and 40 and he can say, oh, 30 runs was scored. Similar to that, if you want to calculate the sum from any I to the jth point, for example, you want to calculate the sum from 1 to 2. What do? Whatever is at this point, whatever is the cumulative sum at j minus whatever is the cumulative sum of I minus 1. Remember this, it's not I minus 1. So in this case, 6 plus 4 is 10, which is 18 minus 8. Similarly, if you want to add these two, it is just 28 minus 14. So this is the general formula. So sum from I to j is just equal to the prefix sum or the cumulative sum at the jth point minus I minus 1. But what if I is equal to 0? It is just whatever is the sum, right? So you can just give it out. For example, 8 plus 6 plus 4 is 18. This is just 18. If I is equal to 0, it is directly prefix sum of j. If not, this is the formula. So why is this even actually important? Why should we even use this, right? We can just sum this up and we can say the answer. For example, you are given these, you want to add from I is equal to 1 to this. You can just add all of these numbers and give the answers, right? Why do you even want to write into this array, that is prefix sum array? Then you want to use a formula and calculate. So I will come into that. I will explain this with a question. So this question was actually asked in Amazon. So this is the given array, and also this is not given. So you are this is the array that is initially given, and you are also given the queries. What are the queries? It includes I and j, and you have to find the sum between these 2 points. For example, I is equal to 2 to 3. For example, this is 14. One way is you can add from 2 to 3, that is 10 plus 4, 14. Then what is the next number? 3 to 5. So you will do it from 3, 4 and 5. Similarly, from 0 to 5 you can add from 0 to 5. Again, from 4 to 9 you can add it, and similarly you can give out the answer. But if you look here, what is the repetitive process that is happening? We are adding the numbers again and again, right? So what is the time complexity here? If there are q queries and if n is the length of this array, what is the maximum time complexity that we have? That is q into n, right? So that is not what we want. We want to reduce the time complexity. So now what we can do is we can form the prefix sum array and we can directly use the formula. For example, what is the formula here? That is just equal to ps of 3 minus ps of 1. So 2 to 3 is just equal to ps of 3, that is 28 minus 14, that is 10 plus 4 is nothing but 28 minus 14. Similarly for this also you can do. Similarly for 0 to 5 is the only difference. What is it? It will directly be 40 because I is equal to 0. If you see in this formula, if I is equal to 0, it is directly the number, else it is one element prior to that. So this is the formula. So let me show you the pseudocode. First thing is what we will be doing is we will form this particular array. This is not given to you. We will be forming this particular array. How do we form this? So the first element will just be equal to the element, right? The first element will be 8. From the second element, whatever is the prior element, we keep on adding that. For example, we add 6 to this, then again we get 14. We add 4 to this and get 18. 18, we add 10 to this 18 and get 28. So what am I doing here? For I is equal to 1 to n, ps of I is equal to whatever is ps of I minus 1 plus the current element in the original array. So this is in the array that you are forming and this is from the original array. After that, what is the second stage? For every query, we just use the formula and we just print the sum. I is equal to the first element, that is this element, then j is equal to the second element, and if I is equal to 0, we will print ps of j. If not, we just use this formula and compute and print the answer. I hope you got the solution for this particular problem. Let's go into the second problem. So in this question, you are given an array and you have to find the pivot index. What is a pivot index? Pivot index is an index such that the elements on the left side, strictly on the left side, is equal to the element strictly on the right side. For example, if you look here, what is the sum here? 8. And what is the sum on this side? It is 17. Is 3 a pivot element? No, right? Similarly, if you look here, what is the sum of 1 plus 7 plus 3? It is 11, right? Similarly, what is on the right side? It is 11. So what is the pivot index here? The pivot index is 3. It's such that all the elements on the left, the sum of all the elements on the left is equal to sum of all the elements on the right. So how do you approach this problem? In the first case, let's start with the brute force approach. Okay, what is the time complexity here? What is that we will be do? We at every I, we will just compute till the sum till that point. For example, if you take this 6, we will compute the sum till this point, and from I plus 1 to again n, we will compute the sum. So for example, so what is the time complexity in that particular case? It will be n square, right? Why? Because for every element we have to iterate again all the n elements, n minus 1 element, so the time complexity will be n square. So how do we reduce this from the algorithm that we know? So let's get into that. First thing is we will form a prefix sum array. And what is the second thing that we need? We also need the sum from the right side, right? So similarly, what we formed from the left side, we will also form from the right side. We can call this a suffix sum array. Similar to prefix sum, we will forming the sum from the left side. That is 6, 11, 17 and so on. Just like you form the left side, we will be forming it from the right side. For example, this is the prefix sum array, and similarly this is the suffix sum array. What does this mean? We just added 1 plus 7 is 8, again plus 3 is 11, plus 6 is 17, and so on. Similarly, we do it in the reverse order. That is 6, 6 plus 5 is 11, 11 plus again 6 is 17, 17 plus 3 is again 20, and so on. So what is the idea that we are doing here? So how do you find it out? What is the equilibrium or the pivot index? You just have to standard this index. For example, you have to standard this index, and if the prefix sum of I minus 1 is equal to this, that is our answer, right? That is the sum of elements on the right. What is the sum of elements on the right for this particular element? That is 1 plus, that is suffix sum 11. And what is the sum of elements on the left side? This is 11. Are they both equal? Yes, they are equal. So this is our element, that is the third element. Similarly, if you want the right and the left sum at this point, what is the left sum? It is 1. And what is the right sum? It is 20. Okay, I hope you got the question. Similarly, if you look at this particular array, the answer is 0 here. Why 0? For example, if you look at the sum of these elements, it is 8. 8 minus 3, that will be 5. So if you take this element, the sum of all the 3 of these elements will be equal to 0. So the answer in this particular case will be our first element itself. So you are excluding this 5, and the sum on the right side is equal to 0, and the sum on the left side, there is no element on the left side. So the answer is the first element, or the index is 0. So this is one edge case that we have to take care of. So what is the algorithm here? First thing is we will form the prefix summary. That is this particular array we will be forming. Then we will be forming this suffix summary. So this is how we form the suffix sum. This is exactly opposite. We started from 1 to n. Similarly, we will start from n minus 2 to 0. And we initiated 0 as a of 0, n minus 1 we will be initiating. Exactly opposite is what we will be doing. And what is the logic to check if it is a pivot index? We start from I is equal to 1 and we iterate till n minus 2. And if the PS of I minus 1 is equal to suffix of I plus 1, then that is our answer. That is PS of I minus 1 equals to suffix of I plus 1. Then that is our answer. Okay, so that is what I am doing here. And there is two special cases that we have to take care. That is, if the suffix sum of 1 is only 0, for example, in this case, this is 0. If that is the case, then 0 will be our answer. Alright. Similarly, on the opposite direction also, if the PS of n minus 2 is equal to 0, we will return n minus 1. So this is the algorithm for the pivot index. I hope you understood this. If you have understood this, we can go into the next problem. Question is an array in this particular problem. So what are subarrays? Subarrays are the continuous range in any given array. For example, 3 minus 1 4 is a subarray. 3 comma this 3 minus 1 is a subarray. Similarly, 4 itself is a subarray. Minus 2 itself is a subarray. Then the entire array itself is also a subarray. So I have written some of these subarrays here. What is the problem? So you have to find the subarray with the maximum sum. Since there are negative elements also, the entire array sum will not be the maximum. For example, in this above example, 3 minus 1 4 is the subarray with the maximum sum. So how do we approach this? Let's just start with the brute force approach. What is the idea here is that we will pick up a I to form a subarray. That will be the starting of the subarray, and there is the j, that is the end of the subarray. That is how I have formed. That is I is equal to 0, then I starts varying from 0, 1, 2, 3, 4. So that is how we form subarrays, not using the length but using the starting and the ending points. So once you know the starting and the ending points, you can just add the elements from the starting to the end point and we can form the sum. So that will be a brute force approach. So what do? We have two numbers, one is sum and one is the maximum sum. What do we do? For every starting point, I will be your starting point. What will be j? J will start from I and it will end at n. For example, if I is equal to 1, since single element is also a subarray, j will start from that particular number and it will end at n. So we form all the subarrays and we calculate the sum. How do we calculate? Again, we have to iterate from I to j. For example, you found out this is the subarray. Again, starting from I to j, we have to form the sum. Once you have formed the sum, the maximum will be either this sum that we got now, or it will be the previous maximum value. That is, we are changing this particular value. Suppose you got 5 as the sum now, and the previous maximum was 3, so we'll update the maximum value. However, if you have 5 now, but the previous maximum value was 7, you don't update that. This is what it means. And at the end, we will just return maximum. So if you look here, what is the time complexity? It is simply equal to n cube. There are 3 for loops, and each will take n time at max. So it will be of the order of n cube. But how do we reduce this using prefix array? We already know, right, from one point to the other point. If we know the starting element and the ending element, we can just easily find out the prefix sum array, right? So we can easily eliminate this if we know I and j. So we can easily reduce from n cube to n square. That is the first thing. However, let's first form the prefix sum array. This is the prefix sum array for that particular problem. So look at this very carefully. So do we even need these two loops, that is the starting and the ending? If you look at this, isn't it similar to the stock problem that we solved in the previous example or the previous video, that is arrays 102? If you haven't watched the video, please consider watching it. Otherwise, I will just explain the video. What is it? It is said the maximum at any point is just equal to that point minus the minimum until that point. For example, what is the minimum till this point? The minimum till this point is -2. So if you add all of these numbers, and if you want the maximum, you will be getting 2, right? 3 and -1, that will be 2. Similarly, if you want the maximum till this point, 4, and what is the minimum till this point? -2. So we will just be adding 4 minus of -2, that will be equal to 6, and that is equal to our answer. So what is it that we'll be doing? We will first form the prefix sum array. After we have formed the prefix sum array, it is just equal to stock problem. That is, we keep track of the minimum element, and once we keep track of the minimum element, at every element we just subtract that element from the minimum element, and we will update the maximum value. So one more improvement upon this is, instead of forming this array, we can just keep track of the prefix sum, right? We don't even need this array. We will just keep track of these numbers, -2, 1, 0, 4 and 3, instead of forming this array. So we'll be saving space also in that particular case. So let me take you to the solution. So instead of forming the entire array, I am just forming the keeping it in a variable prefix sum. This is the minimum until that point. For example, what is the minimum until this point? -2. Similarly, if there was any other number, for example, if there was -5, the minimum value would get updated, but until this point, -2 will be the minimum number. So this will keep track of that, and the maximum number will be nums of 0, and this will be our answer also. Why I directly kept as nums of 0? Because even if you don't get anything, the maximum sum will just be equal to the element, right? Think like you have all the elements as negative, but even if all the elements are negative, the answer will just be one element. So I have just kept this as the nums of 0. So these are the 3 initiations. After that, what do you do? From I to n, you will iterate, and you just form the prefix sum. Instead of forming the array, you are just changing this number at every step. So it will be -2 initially, 1, 0, and this number gets varied. What is the second step? This is what we did in the stock example. What is it that we are doing? We will keep track of the prefix sum, that is whatever is the sum till this point, that is 4 in this case, minus the the minimum value. So that is what we are doing. If this is greater than the existing maximum, we just update it, and the minimum value also, every step we will just update the minimum value. For example, if there was -5 at this point, from this point the minus or the minimum value will change. So that is what we are doing. At the end, we will just return the maximum. Thank you for watching the video. Please do like and subscribe.